Good evening, everyone. Welcome back to our 30 days free short term training from Python to AI friends. We'll quickly understand what we have, you know, understood yesterday. Then we go with a new topic for the day. Right. So, what did we understand as part of yesterday's class? Excuse me. So, in yesterday's class, we have, worked on k-means use case. So, we have understood what is k-means algorithm, how k-means work. In the similar way, we have also understood uh, how k-means algorithm works in real time by taking a project, right? Yes. So, first of all, k-means is an unsupervised algorithm where unsupervised algorithms they work on unlabeled data. Y is not required. Okay, the output column is not required, and this k-means is part of clustering algorithm. Clustering again. What is the meaning of clustering? Clustering is nothing but grouping similar records. How do we identify the similar records? Based on similarities. Then how are similarities identified? Based on distance. So if two records, if two data points, if they have more, if they have more similarities, that means they have less distance between them. This point already we have discussed in the last two classes. If the distance is less between the records, the data points, we can obviously say that the similarities are more. Right. Then, so how do we calculate distance? By the default, the traditional approach using Euclidean distance, we generally calculate the distances between the records. Yes. Then clustering can be of many types: hierarchical clustering, non-hierarchical clustering, then density-based clustering. In this way, there are multiple types of clustering. So yesterday we have understood a project on k-means. K-means fall under non-hierarchical. There is no particular hierarchy followed with respect to the working principle of k-means. Right? So in K means K represents number of clusters that we actually want to group the data. Then upfront we have to define the value of key. Post defining the value of key, the actual algorithm starts. In general, what are the traditional methods used to define the value of key? How do we define the number of clusters? What are the different methods we have, friends? What are the different methods that we have to define the value of key? What did we discuss? Square root of n by 2. This is an old approach which is generally not practiced in the modern days. The reason is this formula doesn't hold true where n takes the value of number of records. Then the widely used approach is elbow curve. Elbow method or elbow curve, also called as scree plot. So we visualize an elbow curve where in elbow curve we'll have k values on x-axis and on y-axis we'll have the inertia, nothing but the within sum of squares. Wherever we see the elbow shape, in the plot, so we can obviously take that value of k. Then what else? Domain knowledge based on the project that we do. Okay, the project belongs to domain, right? So based on the domain we can also take a comment, we can also comment on number of clusters. Okay, if not, customer's requirement. If the customer is having any requirement, yes, we are supposed to go and get the value of k, right? Then we can also uh, define the value of k using Selite score. Using Selite score, yes. So these are the generally followed techniques on which we can define the optimal number of clusters upfront. Then once if k value is fixed, you know, the actual k-means algorithm starts. What is the first step of working under the working principle of k-means? What is the first step? The first step is initializing k centroids. So based on the value that you take for k, you are supposed to take or you are supposed to initialize those many centroids randomly. Okay, this is not you know there is no proper rule to define the centroids, that will be done randomly. So depending on number of records you have, depending on number of data points we have, we randomly select some centroids. If I say 4, these are my 4 centroids. Then what is the second step? Calculate pairwise distances between the other data points and to all the centroids. If I have record 1 here, okay, so distance between centroid 1 and record 1, distance between centroid to record 1, centroid 1, centroid to record 1, centroid 4, record 1. So out of these 4, you'll get the smallest distance. So obviously this will be the smallest distance. So record 1 will be part of centroid 1. In that way, we have to assign. Third step is assigning friends. Then fourth step is continue the process, like post assigning. Since we got clusters formed, we have to recalculate the centroids. So we'll just continue the same process. We'll continue with step 2 and step 3. Still the centroids doesn't change. This is nothing but convergence, right? So the algorithm may run into infinite loop. We are supposed to stop it by fixing number of iterations upfront. If not, we can also fix an condition for convergence criteria. So based on this, the algorithm stops. Right. This is the working principle of k-means. Then once the clusters are formed, cluster 1, cluster 2, cluster 3, so on, how do you evaluate them? How do you tell that these clusters are good clusters or bad clusters? That part we do as part of stage 4 in CRISP-MLQ. What is the stage 4 as part of CRISP-MLQ? Model evaluation, right? So we generally evaluate the clusters that were formed using Silhouette score. Evaluation, yes. So we evaluate the clusters that were formed using the score. What is the formula for Silhouette score? B minus A by max of B comma A. You need not by heart this formula. You can ignore it, because in general no one asks you the formula. But it's better if you remember. That's okay. But the range is important, friends. The range of Silhouette score is -1 to +1. Okay, so if you get a Silhouette score close to 1, that means the clusters that were formed are good. Okay, what if you get a Silhouette score close to -1? The clusters that were formed are bad and they are overlapping on each other, right? So all these things have been discussed, and we also had an experience on a project. What is a project that we have understood yesterday? Customer segmentation. How to segment excuse me. Right. So the project that we have understood is how customer segmentation to be done. Okay, so depending on the various features that we have with respect to a mall, okay, the data was collected and we have the gender, then their age, then what else? Spending score, some kind of score was being captured with respect to their expenditure, okay, spending score, and finally their annual income in dollars. So since the mall is in United States and the customers belong to United States, so what we have done is we took all the columns into the consideration, and initially we found that in annual income there are outliers. We have treated the outliers. Then, since gender is again a non-numeric column, we have performed feature encoding using one-hot encoding, and finally we have performed feature scaling using min-max scalar, so that all the features are into a particular range, that is 0 comma 1. On this scale data, on the final data, we performed k-means algorithm. We performed k-means algorithm. So this k-means actually helped us to perform customer segmentation, where initially we went with the different values of k starting from 2 till 10. Okay, so once after getting the different values of by taking different values of k, we understood what is within sum of squares. Okay, with respect to the scree plot elbow curve, we decided what should be the optimal number of clusters. Then we went forward by taking k as 4. Okay, as an experiment, we went with K with, I mean, 4 clusters, even though you can try it with 3 or 5, wherever you get the good score, wherever the, no, the better clusters are formed, that will be the best K value, right? So, and we interpreted the results. Everything is done. I assume no questions on the previous topic, and I request you guys to also do hands-on by taking any available data sets. Okay, there are publicly available data sets. Okay, so on these publicly available data sets, you are supposed to go and do perform k-means algorithm. Okay, so perform initially EDA, then data cleaning should be done, then k-means, building a model using k-means, and finally evaluating the clusters. All these steps has to be performed, so that if you perform all the steps, you're almost performing an end-to-end project, but still deployment is pending, right? So this deployment, if you deploy a model, it's like covering an end-to-end model. You're performing an end-to-end project, right? So this is what we have understood. Without any further delay, let us continue with the today's topic. Today's topic is very small topic, and this is the simplest algorithm of entire machine learning. Just mark my words. The simplest algorithm of entire machine learning is KNN. K nearest neighbors. KNN stands for K nearest neighbors. Okay, so what is this KNN? First of all, is it a supervised algorithm or unsupervised algorithm? Or if it is supervised algorithm, does it fall under classification or regression? Everything we are going to understand with respect to K nearest neighbors theory part. And the use case for the KNN, we are going to do it tomorrow. We'll do an end-to-end project, including deployment. We are going to understand, friends, this particular algorithm. So pay attention. If you understand the concept well, you can convert the same concept on the coding part as well. Once if the model is built and finally evaluated, you can also deploy it, assuming that model performs well. If it is performing well without any tuning, I can go and perform deployment, right? So before we talk or before we introduce to KNN, I would like to quickly revise the types of machine learning. Okay, what are the different types of machine learning we have? So in machine learning, we have supervised, then unsupervised, and reinforcement. Right. So I'm not, generally touching reinforcement because it's a different topic altogether. But these two hold some similarities. Okay. So supervised supervised algorithms, they work on labeled data, nothing but the data in which there is output column, target column, nothing but Y column. Whereas in unsupervised, you will not have, or the algorithms that are used as part of unsupervised, they work on unlabeled data, okay, where Y is not present. So yesterday we have understood k-means. We have performed a project on k-means. Did we have any output column there? No. Are we predicting anything? No. We are just performing clustering. We are grouping the records. We identify the similarities and we are grouping them. That's it. But under supervised algorithms, under supervised learning, the algorithms are used for predictions. Okay, supervised is classified again into two types. One is classification and the second one is regression. Okay, supervised is again broadly classified into two types, classification algorithms and regression algorithms. Classification algorithms are used for discrete values of y. If there are discrete values in y column, I mean fixed values in the y column, we'll go and use classification. Okay, can you just give some examples for discrete? Yeah, sure. True, false. Okay, if the y column has true or false, only these two values will be part of your y column, target column, output column. They are fixed. You cannot expect a third value to be part of your y column. Pass fail. Okay, so in this way, if I go on, there are n number of use cases, n number of projects with respect to classification. Okay, so the word itself, it is saying classification. We are classifying the classes, categories. Okay, classifying pass category and fail category. Okay, so the algorithms are used on the discrete values. If the Y column has discrete values, we generally go and use classification algorithms. Then we have regression algorithms as well, where they are used if the Y column contains continuous data. What do you mean by continuous data? Hold on. Is my voice not clear, friends? Just confirm on the chat. One of our friend is raising an objection. Is it not clear still? No. Is my voice clear? First of all. Okay. What about others? Is it clear or not? Sometimes it's not clear. Okay. I don't know why, but yeah, it's clear, right? Okay. Thank you, friends. So, for whomever it is not clear, just rejoin the session. Okay. Close it off and rejoin it. Right. So what do you mean by having continuous data in the output column? Simple. See, if you are you know say predicting price of a house or price of a stock, okay, voice is clear. From the background there is a buzzing like sound system. Buzzing sound. Still, I think it should be clear now. Right. So uh, what do you mean by having continuous data in the Y column? It's nothing but you predict some, the value, some kind of value, say predicting temperature. Temperature can be like 30 degrees or say 30.6 degrees Celsius. Yes, this is accepted, right? So when you try to predict something which varies, which is not fixed like discrete, it will be continuous. In general, continuous is nothing but the values which have decimals, right? So predicting price of stock, predicting temperature, then predicting sales, predicting price, all these fall under regression category. So what are we going to do? We are going to predict based on the historical data. The model gets trained based on the historical data and it starts predicting on the new data. Because for the new data, you will not have output. There is no output. So how is Google able to predict tomorrow's temperature at your location? Open Google, okay, then type what is the temperature at 7 a.m. tomorrow morning. It will give you a value what it is doing exactly. So that is the question that we have in the mind. It uses algorithms like time series forecasting. The model gets built initially based on the historical data and it gets trained and it starts forecasting. Okay, it forecasts the results. And this again, the data will be used for training. Continuous training of model will happen, friends, in the backend. Let us not go into the depth of time series because that is not our cup of tea for time being. Right. So we have broadly two types under supervised: classification and regression. So classification is for discrete values under target column, and regression is for continuous values under target column or output column. But today we are going to learn an algorithm called KNN, K nearest neighbors. So the question comes here: does KNN is used? Is it a classification algorithm or regression algorithm? Because is KNN used to predict discrete data or KNN used to predict continuous data? For sure, KNN is a supervised algorithm. Okay, so it's a supervised algorithm, right? But for what purpose are we going to use? It is used for both fronts, not for one. Either for classification or regression, we can use KNN, K nearest neighbors. Oh my God. Are there such kind of algorithms? Yes. We also have, something called as shallow techniques. So under shallow techniques, we have naive, we have KNN, we have decision tree. So these three are used for both. They are used for classification and they are also used for regression. So that means they are capable of working on discrete values as well as continuous data. Right? Then, now it's clear. KNN is used for performing both the tasks, either classification or regression. Okay, so if you have a data set, if you have a data and if you want to build a model for predicting your output column, go and simply use K, irrespective of Y. Why? The reason is it can be used for both the tasks, both for classification and regression. And KNN is a simplest algorithm of machine learning. Why? Why? The simplest ML algorithm is KNN because if you know distance formula, you know KNN is done. The reason is KNN works on the logic of distance, friends. It completely works on the logic of distance. Okay, how the distance logic is used, and what is this concept called nearest neighbors? What is K? Because in K means, don't get confused between K means and KNN, because majority of my students is just confused between these two. I don't know why. K means is an unsupervised algorithm and KNN is a supervised algorithm. Okay, so in K means K represents number of clusters. Then what is K representing in nearest neighbors? Okay, everything we are going to understand step by step. We are slow and steady. Okay, so let us be slow and steady. We win the race. That's it. So it is called as non-parametric algorithm, and it is also called as instance-based algorithm. What is non-parametric? What is instance-based algorithm? We'll understand, right? So this is a crisp introduction about KNN. We'll understand what is this non-parametric and instance-based learning with respect to KNN. 1 minute, right? So lazy learning, it is also called as lazy learning algorithm. The reason is when you start training a KNN algorithm, it does not try to capture the pattern which is actually present in the data. In the historical data, what is the supervised learning premise is? The supervised learning premise is historical data, break it into two parts, train, test. Once the model is trained, take the model and test it on the test data. You'll get predictions, calculate the accuracy, you'll get the test accuracy, get back the same algorithm, same model, get the predictions on train data, you'll get train accuracy, compare train accuracy and test accuracy. You'll get either a right fit or underfit or overfit model. Am I right? Yes. This is what we have understood. But KNN is called lazy learning. The reason is it does not learn anything during training phase. Then what does it do? It stores the complete training data. The entire training data that we have, it stores in the backend, and using that, it makes predictions on the new data. Okay, that is the reason it is called as lazy learning. But how it is capable of doing predictions, we'll understand. Okay, then we also spoke about instance based. What is instance based? It's nothing but completely depending on training data. Whatever the training data that we have, it completely relies on the training data for predictions. Based on that particular instance, it is going to perform the predictions. And non-parametric, we also spoke that KNN is non-parametric. Yes. The reason is, it does not have any kind of assumptions. In general, majority of the algorithms, ML algorithms, they have some kind of assumptions. Like data should be normally distributed. Okay, then it should fall under this beyond range. So there are multiple algorithms where it takes some assumptions on the data, but KNN has no assumption. And in the back end, it does not form any kind of equation. There are no parameters. So that is the reason it is called as non-parametric algorithm. Right. So we'll understand the working principle of KNN. So it's very simple, friends. If you understand the distance topic, job done. That is the reason it is a simplest algorithm of machine learning. So let us understand the steps. Initially, you have to define K. What is K here? K is nothing but number of neighbors. K nearest neighbors, right? So K is representing number of neighbors. Okay. So initially, consider our select the values for K. Okay. So some values like 1, 2, 3, so on, whatever. Then compute the distance between the new data point and all the points in the training data set. So in the training data set, you'll already have the data. Then this new data point that we have, whatever the new data point that we have, we are supposed to get the distance between the new data point and the existing data points, the existing data. How? Using distance. So by default, again, Euclidean distance will be used. If not Manhattan, Minkowski, Mahalanobis, there are multiple distance formulas used. Different scientists, they came up with different formulas. At the end of the day, depending on the distance that you use, you'll get the results. Okay. So based on the value of K that you select, okay, you'll get the nearest neighbors for your new data point. If this is your new data point, depending on the value of K that you take, okay, you'll get the distance is calculated. And if it is a classification problem, you go for most frequent value, the majority value. So out of these nearest neighbors, what is the majority category that you have? So this new point will be taking that class. Okay, so we'll go with an example. Don't get any kind of thing. We'll understand with an example, right? But for regression, it goes for an average. Depending on the neighbors, it takes all the average of the neighbors. Okay, so let us understand with an example with respect to the same steps one by one. I had a small example here so that you'll understand well. So this is predicting students' grade, a use case, and in the table I have the details of 6 students depending on their hours that they have invested for studying. 10 hours, 7 hours, 4, 8, 6, 2, different student, different capacity. Accordingly they'll invest their time for studying. And depending on the number of hours they studied, we also have one more feature: how many assignments that were completed. Okay, so the first student completed 8, then 6, 3, 7, 5, 1. So 6 students, these are the number of assignments that they have completed. Depending on these two categories, feature 1 and feature 2, we are predicting Y. What is Y here? Grade category. Okay, so this is the historical data that I have. That means I already have this data. Student 1 studies for 10 hours and he or she completed 8 assignments. So his grade is good. He got a good grade. The category that he or she falls under is good. Okay, by taking again the same values of student 2, his category is under average, then poor. So first of all, what we have to do is we have to identify what problem it is. It is purely a classification problem. Why? Because what values do you see under Y column? I see discrete values. Yes. So if it is discrete, obviously it will be a classification problem. Okay. Classification problem. What are the number of classes that you have? Classes represent the unique categories. Good is one class, average is one class, Poor is the third class. Again, the same classes got repeated. So how many classes we have in total? There are three classes. Three classes. Okay, good, average, poor. Right. Now, what I'm doing is I take this data as it is. On x-axis, I'm plotting hours, the first feature, and on y-axis, I'm just taking the second feature, assignments completed. So it for better understanding, I'm taking this, friends. Okay, so what is the first student? 10 comma 8. So 10 will be somewhere here and 8 is this one. So I'll just mark with the student ID. This is 1. Student 1. Then second student is 7 comma 6. 7 comma 6. This is student 2. Third student 4 comma 3. 4 comma 3. Third student. Fourth student 8 comma 7. 8 comma 7. Fourth student. Fifth student 6 comma 5. 6 comma 5. Fifth one. And sixth student is 2 comma 1. So this is sixth student. So all the six student, for visualization purpose, I took it on two-dimensional axis, x-axis and y-axis. Okay, and I'm visualizing their results. And I'm also giving a color code for the three different classes. For good, I'm marking it in green category. For average, I'm marking in blue category. And for poor, I'm marking in, excuse me. Sorry, friends, it's not good for me. That's okay. Um, for poor, it is like, kind of red that we are actually taking. Now, the challenge that we have is, it's not a challenge, it's a task for us. We have a new student coming into the class. Okay, so for the new student, what is his hours of study is 6 hours. He studied for 6 hours and he have completed 4 assignments. We are supposed to predict under which category does the student fall under. Okay, so we have a task with us and we are supposed to predict for the new student, the category for the new student. For that, what I'm supposed to do, first of all, I have to build a model. This model will help me for prediction. Okay, since we have understood KNN is very small, a small topic, let us go and apply KNN algorithm on the data. So when a new record comes into the picture, what does the first step is? You have to fix the value of k, right? So I'll keep this k value aside. I'll jump into the second step, calculating the distance between the new point and the existing records. So 6 comma 4 with 10 comma 8. Calculate the distance and tell me. The first student is 10 comma 8 and the new student is 6 comma 4. So x1 y1 x2 y2. Calculate the distance. It will be 10 minus 6, 4. 4 square 16 plus again 8 minus 4, it is 4 again, 4 square 16, square root under 16 plus 16 nothing but 32. So it is nothing but 4 root 2, 4 into some kind of 1.1414. Root 2 is nothing but 1.414. When you multiply both, you get the output. In the same way, I have to calculate for 6 comma 4 with second student, third student, fourth student, fifth student, sixth student. I'll do the same process for all the students and I'll get the distances calculated with respect to each student. So I have marked the new student here. New student is here, 6, 4. So the distance with first student is this one, distance with second student is this one, distance with third student, distance with fifth student, fourth student, distance with fifth student, and distance with sixth student. All the six distances I have to calculate. That is what the second step talks about. Calculate the distance. Either you can use Euclidean, Manhattan, or Mahalanobis, Minkowski, anything. Right? Once after calculating the distance, now based on number of k values that you take, okay, you can predict the category for the new student. For example, if I take k is equals to 1, assume. Let me remove these lines because you may get confused. Right. So if I take k is equals to 1, that means taking one nearest neighbor. So what is the nearest neighbor that I have for the new point? Obviously this one. It's better if I go with new color. Obviously this one, yes. So what is the category of 5? The category of 5 is average. So the new student also takes average. So it predicts that new student fall or take a grade average. Nothing. It's simple, friends. Depending on the distances, once the distances are calculated with respect to all the data points, you have to go with the values of k. What if I take k is equals to 2, not 1? So what are the two nearest distances? Might be this one and this one. Yes. So this will be my boundary. So what is the class of second student? Average. What is the class of fifth student? It is also average. So obviously the new student will again fall under average. No, it will take 3. Okay. If I take 3, if I take 3, so might be this one, it will be like this. Yes. So this student says average. This student is also falling under average. What about third student? He falls under poor. Now in this case, Akhil, what is the majority class? The majority class is again average. So even if k is 3, if 3 nearest neighbors are taken into the picture, still the new student falls under average category only. No, Akhil, take 4. Take 4. Okay, let me take 4. Might be this one like this. This might be my circle. Yes. So what is the category of fourth student? It is good. So again, what is the majority? It says average. So even if k is 4, the new student falls under average class. So in this case, depending on the same pattern, the prediction gets changed. Is there any machine learning here? That is the reason it is called as instance-based learning. Lazy learning algorithm. It completely depends on, you know, distance logic. Once the distances are calculated, keep the distance matrix aside and you fix the values for k. How should I fix the values for k? We do cross validation. We take different values of k and we check with the results. Wherever we get the best results, we finalize that value of k. But Akhil, there should be some tips, right? So that accordingly we can take the value of, we can suggest the value for k. Yes. Initially, the widely used, rule to fix the value of k is k depending on the labels, the categories that you have. For example, if you have binary category, that means only two classes are present. Don't take the multiples of the class. That means k should not take 4, k should not take 4, 2, 6, so on. Because why? If you take these values, these multiples for k, there might be chances of getting ambiguity case. What if you have a tie? Okay, for example, assume my friends, there are two classes, pass, fail. Pass, fail are the y values, assume. So how many classes? Two classes, right? So don't take the values of 2, 4, 6, so on. Don't take the values of two multiples for k values. Why? The reason is if you take k is equals to 2, that means two nearest neighbors, right? So what if one of my neighbor is pass and one of my neighbor is fail? And if I have my new data point sitting here, to whom should I go? Should I assign it to pass or fail? This is called as data ambiguity. Ambiguity, coming into the picture. Here we cannot, the model cannot predict anything. That is the reason we avoid the multiples of class in simple. So here also it's better if we avoid 3, 6, so on. But still, since they are odd numbers, we can go with. In general, K takes odd numbers. So I hope it's clear. And this is how KNN works. Okay, yes, nothing but 50-50 chances. So it's not possible for us to predict whether the new student should be declared as pass or fail. So impossible. Even if you have taken K value as 4 and if you have data like this is my new data point, or let me keep like this. I'm taking K value as 4. So 4 classes, I mean 4 nearest neighbors, and this is my new data point. Now tell me, out of these 4, 2 are pass, 2 are fail. So what class should I give for this new student? Should I give pass or should I give fail? Data ambiguity case. So that is the reason we avoid the values or multiples of classes to the values of k. Right? So you need not memorize. There is not, or I should say, to be frank, to be honest, there is no much concept involved under KNN. It's a very small, simplest algorithm of machine learning, but it is used for both classification and regression tasks. It is a widely used algorithm in real world, very widely used. Okay, so we'll understand what are the challenges, what are the advantages we have, what are the applications of KNN, everything we'll understand. Then we'll go with the use case probably tomorrow, friends. So first of all, we'll talk about advantages and limitations of KNN. So advantages, as we discussed, it's a very simplest algorithm, and implementation is also very simple. You need not get worried about the understanding and all. In order to understand, even a kid can understand KNN algorithm. The reason is it is purely based on distance logic. Then the advantage of again KNN is it works well on small data sets. If the data set is very small, okay, small is also representing features. If you have say 1,000 or 10,000 records and probably 15 columns, 15 features. Okay, KNN works well compared to having 10 lakh, 1 million records and same 15 features might be, because this is treated as, it is no more treated as small data set. It is not even a small data set. Why? What is the reason for that? For everything, this is the answer. Distance based, right? So it computationally it is expensive. It keeps lot of burden on our CPU. The reason is it takes lot of time to calculate all the distances. For that reason, it is not widely preferred on large data sets. If you have millions of billions of records, it is not preferred. right? Then sensitive to irrelevant features, nothing but if you have multiple features coming into the picture, you are supposed to perform scaling for sure. Scaling has to be performed before we go and build KNN model. The reason is if you don't perform feature scaling, again the model gets biased towards any one of the feature, and the results will be worst. And the third limitation of KNN is dimensionality, friends. Okay, so probably if you have, that's what was discussed. If you have more, or if you're working on a large data, KNN is not a good algorithm preferred. That's what we have understood. It takes a lot of time to compute all the distances, as well as you know it takes a lot of efforts to do all these things, right? And the final one is the applications. As we discussed, for both classification and regression, whatever might be the use case, we can simply go and go with KNN algorithm. Again, specifying the limitations and advantages, we can go with either classification or regression problem. So this is the use case that we are going to do it in the class tomorrow, classifying diseases. Okay, so probably we'll discuss a use case with respect to life sciences healthcare tomorrow in the class using KNN. How KNN helps us to predict a disease in real world is what we are going to look out in tomorrow's class, including deployment. Probably deployment cannot be done tomorrow itself, might be on the next day, Friday. Okay, so how it classifies a patient with the disease and a patient with no disease. Okay, patient having cancer, patient not having cancer. Everything we are going to see. Okay, so these parts we are going to understand probably in the next class. Then we can also classify images based on its pixel, right? So this is again different topic. Let us not talk about this more, because this again talks about unstructured data. So far we are just discussing only structured data, right? So let us not focus on it. Then coming to regression, yes, predicting house prices, predicting salaries of employee, okay, predicting sales of a company, predicting profits of an organization. So all these come under the use cases, the projects for KNN, okay, where KNN can be applied. Okay, then estimating user ratings in recommendation engine. One of the widely used recommendation engine is YouTube, Netflix, then Amazon Prime. All of these are recommendation systems, right? So we can also predict the user rating for a particular show or a movie or whatever it might be, telecasted in a recommended system. That can be done. So these are some of the applications that we have with respect to KNN. But KNN, to be honest, it's not a tough algorithm in machine learning. It is considered as the simplest algorithm. The reason is if you know the distance formula, you're done with KNN concept. It's very simple. Only thing you can expect questions from KNN is the evaluation metrics that you are going to consider. What are the evaluation metrics? Evaluation metrics generally change, friends. For classification problem, evaluation metrics will change, and regression problem also, the evaluation metrics change. So tomorrow we are going to understand something called as confusion metrics. What is confusion metrics? What are the different you know topics that we have under confusion metrics, and possibly classification report. We'll see. Might be if time permits, we'll do it tomorrow itself. If not, day after tomorrow, because these are something important with respect to interviews. In interviews, you can expect questions from these topics. Okay. Then what else? Accuracy, this is already discussed. So we are going to talk about accuracies tomorrow. How accurate is the model performing? Because we did not discuss about accuracies in case of k-means. Why? Because k-means is not a supervised algorithm, right? Are you predicting anything? No. Then how can you talk about accuracy there? Just you are evaluating your model. Did you get good clusters or not? If you got bad clusters, go and redo the algorithm. Build the algorithm, build the model again, get the clusters formed again, evaluate them again. But there is no point of talking about accuracies in unsupervised learning. So we'll discuss about accuracy. Probably error we will not discuss. This is a part of regression. So the use case that we are going to discuss will be on classification fronts. So I request everyone now to join tomorrow's class as well, so that you'll map the use case as is, right? So 1 minute. Yep. So this is the last slide that I have. So that's all for the day. And if you have any kind of technical questions, what if our model works well on the training data and fails on the tested data? Simple. We have to do the training process again. There is something called as tuning, friends. Okay, so we are supposed to work on the tuning part. In the sense, see, um, I'll just map it again with the student. What if a student does not train well and assume that I have, before sending to the interview, I have tested the student. Okay, if he or she is not performing well, will I send him to the interview? No, right? Obviously, no. What I have to do? I have to retrain him. I have to tune him, tune her. How? Right? So, by passing additional parameters, we tune the student. In the same way, we have to tune the model. So, when you tune the model, it starts predicting. Still, what if the model or student is not assume? Let us not consider student. Okay, so by chance, what if you say the model is not even predicting? If it is not even you know predicting properly on the test data, then what can we do? We can simply say that that particular model is unfit for our data. Then we can go with the next model. See, as we have discussed, for classification problems, there are n number of algorithms. It's not only one algorithm, right? So that's what I'm telling you. It's not only one algorithm that we have. We'll try with one, we'll experiment with the first algorithm. If it is working properly, if it is giving good results, we'll go with that algorithm. We can deploy it. But what if it is not doing properly? If it is not giving the results properly, we'll go with the next one. So this is kind of experiments, friend. So that is the reason we are named as data scientist in the real world, ML engineer. We are literally doing the job of a scientist by doing a lot of experiments. I hope it clears your doubt, my friend. Yeah, any other questions? Good question. Any other questions? Yeah. Come on, friends. Any other technical questions? Okay. Assuming no questions, I think yes. You know, the feedback link has been provided. Yeah, cross validation and all. It's a different topic. You know, that can be discussed probably tomorrow, because we used cross validation for the taking the value of key. Okay. The coding in Spider is useful in which other languages? Probably only Python. Only Python, friend. Yeah. So, friends, the feedback link has been provided. So please fill it before you leave, and also make sure that you hit on the like button if you feel the session is, you know, amazing. If it is great, just hit on the like button. And also, if you are doing hands-on and if you are stuck up anywhere, I have already informed you earlier. You can use the comment section, post your comments. Okay, so we'll reply to your comments. If you are stuck up anywhere with respect to your hands-on. Thank you, friend. Right. So that's all for the day. Thank you so much for joining today. Probably we'll see you all of you in the next class, and we'll discuss the next topic. Until then, take care. See you. Signing off.